Hello, I'm your instructor, John Michael Reed, and this is the first of a four-part series called Computer Lessons for Seniors. This is lesson 1 of 4. This lesson covers data storage, bits, bytes, data, memory, and information. It also covers the parts of a computer. But first, before we begin this class, we need to do a quick vision check. Everyone should be seeing an optometrist. So for example, I wear eyeglasses. Typically, your optometrist would ask you to read some letters to see how good they'll test both your near vision and your far vision, your eye doctor. You should also have clean eyeglasses. This is a search on Amazon for eyeglasses cleaner. There's a spray and there's also these microfiber cleaning cloths. I personally am very, very nearsighted, so my glasses are pretty thick. So what I personally do is I get a clean cotton shirt, and I will clean my glasses with the clean cotton shirt. Most shirts, most clothing leaves streaks, but 100% cotton usually doesn't. So I use 100% cotton, or I can use microfiber. But at the beginning of a class, make sure everyone has clean glasses. Clean your glasses. If you're not able to read a book or if you're not able to see up close, make sure you go to your eye doctor. Computers require you to be able to see things that are up close. We will start our lesson with a video, a couple short, like 2-3 minute long videos from YouTube. We will search for computer lessons for seniors, computer basics for seniors. We'll start with what is a computer?
Hello. I want to play this.
This is a commercial, you can ignore it.
With your groceries? This journey with childhood cancer comes at you in
Okay, I don't
waves.
want this commercial,
Every
we'll
day
have
we
to
wake
skip
up
over this.
knowing that our 2-year-old has cancer. It's tough to get through.
I apologize for the
Is about the size of a
commercial.
baseball. I believe in the power of hope, and from the
Give me a second.
Computers are all around us. From laptop computers,
There it is.
smartphones, to smartwatches.
So to start the video,
Computers are all around us. From laptop computers, to smartphones, to smartwatches. They're changing the way that we live our lives. But have you ever asked yourself, what exactly is a computer? A computer is an electronic device that manipulates information or data. The computer sees data as ones and zeros, but it knows how to combine them into much more complex things, such as a photo, movie, website, game, and much more.
so I'm just going to say that computers they don't really understand like English or human numbers like base 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Computers only understand internally, the CPU, the thing that executes the computer instructions, only understands binary, which is zeros and ones. And long series of zeros and ones are converted into things like letters or colors or light on or off. And then the computer basically interprets this binary, these zeros and ones. So let's go back for a second.
Complex things, such as a photo, movie, website, and much more. Computers use a combination of hardware and software. Hardware is any physical part of the computer, which includes the internal components and the external parts like the monitor and keyboard.
So hardware is called hardware because you can physically touch it. It's hard. Whereas software can be configured by changing code. So it's considered soft, it's considered changeable. That's why it's hardware and software.
Software. Hardware is any physical part of the computer, which includes the internal components and the external parts like the monitor and keyboard. Software is any set of instructions that tells the hardware what to do, such as a web browser, media player, or word processor. When most people say computer, they're talking about a personal computer. This can be a desktop computer or a laptop, which has basically the same capabilities, but in a more portable package. Personal computers come in a few different styles. The most common type uses the Windows operating system. Macs or Macintosh computers feature the Mac OS operating system, while Chromebooks run on Chrome OS. Smartphones and other mobile devices mostly use the iOS or Android operating systems. We'll talk more about operating systems in a later video. Computers come in many other shapes and sizes. TVs, game consoles, and even appliances like refrigerators can have built-in computers, although they may not do everything a desktop or a laptop can. There's another type of computer that plays an important role in our lives: servers. A server sends information to other computers on a network. In fact, every time you use the internet, web servers deliver the web pages that you want to see to your computer.
So servers run an operating system too. Most servers don't run Windows or Mac the way your personal computer does. Most servers run an operating system called Linux. Linux is also used for desktop computers by computer programmers because it's just convenient for them to have the same operating system on their tooling work computer as on the servers they deploy their code to, or they deploy their web application or web server code to. But yeah, so the 5 operating systems that you see are Windows, which is most common on desktop PCs or laptop PCs, Mac, which is less common than Windows, Android's operating system, the iPhone operating system, iOS, and lastly Linux for servers.
Servers are also used in many offices to store and share files. As you can see, there are many types of computers out there, and each one plays a part in our modern world.
GCF Global, creating opportunities for a better life.
Okay, so that was the first video. We're also going to learn the parts of a computer. We're going to get to that later. So let's first get to our slides. So computer lessons for seniors, data storage, bits, bytes, data, memory, and information. So first we do our vision check. We clean our eyeglasses to make sure we can see. If we can't see, maybe we need to visit our eye doctor. I try and visit my eye doctor every year. Then the parts of the computer. I'm going to talk about the parts of the computer here, and then we're going to watch a video. So there's the CPU, that's the brain of the computer. CPU stands for Central Processing Unit, and it executes computer instructions. So whenever a computer processes data, whenever it moves things around, moves around data, the CPU does that. Then there's the RAM, which stands for Random Access Memory, which is the short-term memory of the computer. The short-term memory is the memory that the computer uses while it's doing calculations, while it's figuring stuff out. It uses RAM. For file storage, like storing your Word files on your computer, storing your MP3 music files, storing your MP4 video files, those get stored on the hard drive, which is for long-term storage on the computer. The RAM gets wiped every time the computer is turned off. The hard drive does not get wiped every time the computer gets turned off. So the hard drive is for lasting storage. Then there's this thing called the motherboard, which the CPU, the RAM, and the hard drive all connect to. I'll show you, we'll get to a video right after this where it shows you all the parts with like pictures. There's your monitor. I mentioned servers. Servers come on racks. They don't come with a monitor, but your desktop computer comes with a monitor. Your laptop has a monitor connected to it. Even your phone has a monitor on the front that you look at. Your desktop computer has a mouse and keyboard. Servers are usually connected to remotely. Like a programmer will connect to a remote server and like send some computer code to it, maybe to update like a website or something. There's a graphics card that lets you connect to the Wi-Fi. Laptops come with the graphics card pre-installed. Desktop computers, you can buy a graphics card, or it can come with the desktop computer when you buy it. Oh, sorry, I meant wireless. I was meant to say wireless card. But yeah, wireless card connects to Wi-Fi. So laptop computers come with a wireless card pre-installed, or desktop computers, you can buy a wireless card and connect it to the USB port, or the wireless card can come pre-installed. Lastly, there's the graphics card. When people want to play video games with like 3D graphics, it'll use the graphics card. Also nowadays with AI and machine learning, those use NVIDIA graphics cards usually for parallel processing, parallel computing. We'll get to a video explaining all these parts of a computer right now. I know it sounds very complicated, but the video will make it simpler. One second. Computer lessons for seniors. Computer basics for seniors. Okay, so now we're going to go over computer basics inside a computer. And we'll also do basic parts of a computer next. This is a commercial. I apologize. Let's skip this commercial.
You may already know that there are many important parts inside a computer. But what exactly do they do? Let's take a look inside and learn about the various components that make a computer work. Whether it's a desktop computer or a laptop,
So that green board that you see, the big green rectangle, that's the motherboard. And then the different parts connect to the motherboard. So you've got RAM connected to the motherboard. There's a CPU with a fan over it connecting to the motherboard. So the left is a desktop computer, the right is a laptop computer. But we'll go from there.
Every computer has a large circuit board called a motherboard. This contains some of the most important parts of the computer, such as the CPU, also known as the Central Processing Unit or processor. The CPU can be considered the brain of the computer because it processes information and carries out commands. Since it tends to get hot, it's covered by a piece of metal called a heatsink, which draws heat away from the processor. The motherboard also contains the computer's RAM, or random access memory. This is the short-term memory that the computer uses whenever it's performing calculations. However, you cannot store your files there, because the RAM is cleared when you shut off the computer. The hard drive provides long-term storage, keeping all of the computer's data even when it's turned off. Many hard drives use a magnetic platter to store data, but many newer computers have solid-state drives, which are faster and more durable, but also more expensive. On many desktop computers, the motherboard has expansion slots that allow you to upgrade adding expansion cards. You can add a video to get better graphics performance, or you can add a wireless card to connect to your wireless home network. Most laptops, however, don't have expansion slots. Of course, the computer's components need electricity to run. The power supply unit is designed to take power from the wall outlet and send it to all of the different components that need power. Laptops also contain a built-in battery that lets you use them anywhere. A computer is a pretty complex machine, but now that you've seen what goes on inside, it should be a little less mysterious.
GCF Global, creating opportunities for a better life.
There are many different types of computers, but they all use similar parts to operate. In this video, we're going to show you what these parts are and what they're used for, starting with a standard desktop model. The computer case holds the main components of the computer. This is where the actual processing happens. Today, most cases are what we call tower cases, which means they stand up vertically, but they can also come in other shapes and sizes. To view things on your computer, you'll need a monitor. The monitor uses the video processor inside your computer case to display images, text, and other content. Most monitors
looks like we're getting maybe...
have
There
an
we go.
LCD or LED display, both of which are very thin so they don't take up much space. All-in-one models are even more compact since they combine the monitor and the computer case into a single unit. To interact with your computer, you'll need a keyboard and a mouse. Keyboards come in many different styles, including wireless and ergonomic. The mouse is used to control the mouse pointer on the screen, so you can click and interact with your computer. Most mice detect movement using an optical sensor on the bottom. Underneath you'll find a small electronic eye. Laptops combine all of these things into one. That includes the components that are normally inside the computer case, plus a built-in screen, keyboard, and touchpad. The touchpad is a small touch-sensitive area that takes the place of a traditional mouse. It lets you control the mouse pointer in a drawing motion with your finger. Laptops offer the best of both worlds when it comes to portability. You can use them on the go thanks to the built-in battery, or you can connect a separate monitor, keyboard, and mouse, effectively turning your laptop into a desktop. So those are the basic parts of any computer setup. As you can see, each part plays an important role, which you'll come to understand as you spend more and more time with your computer.
GCF Global, creating opportunities for a better life.
Oh, nope, I don't want to click that. Let's get out of this. Okay, so we just finished, we did what is a computer, we did inside a computer, and basic parts of a computer. Okay, now that we've done that, we'll go back to the slides. Okay, so we've talked about the parts of the computer, the CPU, central processing unit, the RAM, random access memory, the hard drive, the motherboard, the monitor, the mouse and keyboard, the wireless card to connect to Wi-Fi, and the graphics card for 3D graphics, like to play video games. Bits and bytes. We're going to go one point at a time, starting with the first point. So internally, computers only understand zeros and ones. So inside of a computer, when you think of a file, like a Word file or a music file, an MP3 file, or a video file, an MP4 file, Files are just a series of zeros and ones, 0011, 0011. And the computer interprets those zeros and ones as some sort of program, as some sort of thing that needs to be interpreted to create something that you look at in the word processor, something that you watch on the video screen. But internally, computers only understand zeros and ones. They understand zeros and ones is called binary. So a bit, one bit, single bit is a single 0 or 1 in a computer. A byte is 8 adjacent bits. So for example, 0101, that's 4 bits. And then if you have another 0101, together that makes 8 bits. So we're on the second bullet point. So 8 adjacent bits is a byte. You may have seen something on the computer say like 5 KB, 5 kilobytes, or like 5 MB, 5 megabytes, or even like 1 GB, 1 gigabyte. So a kilobyte is 1,000 bytes. That's how much space something takes up on a computer. That's how many zeros and ones it takes up in the storage of the computer. It's 1,000 bytes, 1 kilobyte. When you think of kilo, think of like kilo is 1,000. So for example, if you think of like the metric system, how many grams is in 1 kilogram? A kilogram has 1,000 grams. Then more than a kilobyte is a megabyte. A megabyte is about 1,000 bytes, no, not 1,000, 1,000,000 bytes. 1,000,000. A megabyte is 1,000,000 bytes. So for example, a megaton is 1,000,000 tons in the metric system. So we're going by metric system. We're not going by, these aren't like American units, these are like European metric system units, but that's what the standard for how computers' memory and storage is calculated. Bigger than a megabyte is a gigabyte. A gigabyte is 1 billion bytes. So there are about 1,000 megabytes in a gigabyte, where a gigabyte is 1 billion bytes and a megabyte is 1,000,000 bytes. So think like giga, G-I-G-A, as 1 billion. Lastly, the biggest size we're going to list is a terabyte, which is 1 trillion. You can think like tera starts with T and trillion starts with T. These units of measurement can be used for things like RAM, hard drive storage, etc. So when you go to like Office Max or something and you buy a computer, they might say something like, this computer has 4 gigabytes of RAM. That means it stores 4 billion bytes in its random access memory, in its RAM. Or someone might say, you might buy a desktop computer online or at Office Max, and they might say, this desktop computer has 1 terabyte of hard drive disk, 1 terabyte of storage. So a tera is trillion. So a terabyte of hard drive disk is a trillion bytes of storage. Or even you might look at like your phone, like your iPhone or something, and they might say something like, this iPhone has 200 gigabytes of storage. So the giga is billion, so that's 200 billion bytes of storage in your iPhone. Same thing with Android. They might say this Android has 4 gigabytes of RAM and 100 gigabytes of hard drive disk storage. So those are bits and bytes. Now we're going to talk about how humans count versus how computers count. Humans count in base 10. So humans go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whereas computers only understand zeros and ones, so they count in a system called binary. So a computer would start 0 is the same, just 0, and then 1 is the same, just 1. But then it would go 1, 0 is equivalent to the human number 2, 1, 1 is equivalent to the human number 3, 1, 0, 0 is equivalent to the human number 4, and then it goes on. 1, 0, 1 is equivalent to the human number 5, 1, 1, 0 is equivalent to the human number 6, 1, 1, 1 is equivalent to the human number 7, 1, 0, 0, 0 is equivalent to the human number 8. Internally, these computer numbers can be converted into things like characters. They can be displayed as letters in your Microsoft Word or in your Notepad word processor. But computers interpret binary numbers in different ways. And depending on how they're interpreting these binary numbers, they produce different things. They can produce like letters in your Word document, or like pixels on your screen, or instructions in your video game, something like that. The CPU, the central processing unit, the brain of the computer, interprets binary numbers. So it interprets zeros and ones as CPU instructions / commands. There's this type of programming called assembly programming, which is the lowest level of programming, where they end up directly putting zeros and ones into the commands, into the CPU, and the CPU executes those zeros and ones, those series of zeros and ones. The Windows operating system, the OS of like your desktop computer, can interpret a series of zeros and ones as a file. For example, a .docx file, a Word document. Each file on a computer takes up a certain number of space, usually measured in bytes. You can have like a 5 kilobyte file, a 5 megabyte file, a 1 gigabyte movie on your hard drive disk. And each file usually has an extension, like .docx. So if the extension is .docx, that's a hint to the operating system that this file is supposed to be interpreted as a Word document. If the extension is .mp4, that's a hint that this file is supposed to be interpreted as a movie. A .mp4 file is a video. If the file extension is .jpg, it's a hint to the operating system that this file is supposed to be interpreted as a photo. Photos are saved in JPEG format. It's a compressed format. But basically, all of these files, whether it's a JPEG photo or a Word document or a video, are just, to the computer, they're just series of zeros and ones. Many, many zeros and ones, sometimes billions of zeros and ones. Where a billion is a gigabyte. Giga is billion. But your computer, will take these zeros and ones and interpret it as a Word document, as a photo, as a video, and it makes a decision how to interpret it, which program to use on it, based on the file extension. The .docx at the end of the file for Word, the .jpeg for photos, .mp4 for videos, and so on. So binary numbers, these very long series of zeros and ones, can be interpreted as characters, like for a Word file, documents. They can be interpreted as music, .mp3, as photos, .jpeg, etc. The file extension, example .jpeg, .docx, .mp4, etc., is a hint to the operating system on how to interpret this data or this file. It's a hint saying, hey, this file extension is .docx, maybe you should open it using Microsoft Word. The operating system, you can think of it as like the first program that, it's like the program that kind of navigates and negotiates between all the other programs. So like think of like Windows. Windows is like the operating system, and Windows can say like, hey, open up Word, or open up Excel, or open up the web browser. And Windows might say like, hey, I'm going to give Word most of the priority for CPU time or whatever. But yeah, the operating system is the program that's in between all the other programs. It's like the traffic cop of the programs. Sometimes it's the first program that opens up before the other programs do. So this is a CPU, a central processing unit. It doesn't have the cover on it, so you can't see any metal cover. This does have the cover on it. And if you look closely at this, you'll see that this CPU is a multi-core processor. It's 4.2 gigahertz, 12 megabytes of cache, 64-bit CPU. You don't need to worry about these numbers too much. In general, the higher the gigahertz, in general, the faster, although it's not like guaranteed. And in general, multi-core means it can do like multiple things in parallel. So a single core CPU can only do like one thing in parallel. A multi-core can do like two things in parallel. Like a dual core can do two things in parallel. A quad core can do four things in parallel. Well, sometimes if you're not doing anything in parallel, it doesn't make sense, but we don't need to worry about that too much. Nowadays, most computers are x64, 64 bits. When I was little, the computers were 32 bits, but 64 is newer than 32. Okay, now we're going to talk about main memory, also called RAM. RAM is short for random access memory. It's the first bullet point. Now we're going to go to the second bullet point. RAM is called that, random access memory, because unlike hard drive, its data can be accessed randomly, non-sequentially, with little performance impact. So random access memory is accessed all over the place, randomly, where the access jumps around, whereas hard drive disk, traditionally it's a spinning disk, it's accessed sequentially. So hard drive disk is really good for things that are accessed from beginning to end in sequential series, so like a movie, a song, whereas like if you listen to an MP3 file, you start at the beginning of the file and you progress to the end of the file. You're not constantly jumping around. Or same thing with a movie. You start at the beginning of the movie and you watch it to the end of the movie. That would be like an MP4 file saved to hard drive disk. So RAM is faster than hard drive storage, but again, whenever you turn off the computer, it gets wiped. Whereas hard drive doesn't get wiped when you turn off the computer. So that's the second point. That's the fourth point. RAM is wiped every time the computer is turned off. Programs use RAM for temporary storage, like for computation. Different programs and different operating systems have different RAM requirements. So if someone might use a certain program, the program might say like this program requires 1 gigabyte of RAM, or like there might be a video game saying like this video game requires 2 gigabytes of RAM, something like that. Each program has its own RAM requirements, where a given computer will have multiple programs installed on it. It's normal for a computer to have a few gigabytes of RAM. For example, a computer can have 4 gigabytes of RAM, it can have 8 gigabytes of RAM. We're going to take a look at RAM. So this is a photo of RAM that goes in a desktop computer. Computer RAM, random access memory. It's this green rectangle. The gold teeth at the bottom, that's the part that attaches to the motherboard. Here is RAM attached to a motherboard. There's 4 sticks of RAM. Each stick could be like 1 gigabyte or 2 gigabytes of RAM. So this could be 4 gigabytes or maybe 8 gigabytes of RAM, or maybe it could be as much as 16 gigabytes, I don't know, but those green sticks right there are the RAM. The metal square over there on the upper left is the CPU. It's got the cover on it. There are other things here, like there's maybe a port for attaching your video monitor with the those like the white on the right there. Next, we're going to talk about mass storage, hard drive. HDD is short for hard drive disk. It's called that because it has a physical disk that spins, like a CD. Hard drive disk stores more data, more zeros and ones, more bits, at less cost than RAM. Unlike RAM, hard drive disk persists after the computer is turned off. Programs use hard drive for long-term storage, like files. It's possible for a computer, like a desktop computer or a server, to have a terabyte or more of hard drive disks. SSDs, solid-state drives, a solid-state drive is sort of like a USB. There's no spinning disk, and an SSD is a type of hard drive that has no spinning disk, and it costs more than a hard drive disk. But it's faster, especially in non-sequential memory access. So accessing data or accessing memory that's not in one contiguous strip. I'll show you pictures of these. So this is a hard drive disk. You'll see it has an arm. Right there is a metal arm that goes to the position on the disk where the data is being read from. And the silver circle is the disk itself, that spins. These are the parts of the hard drive disk. There's the read-write head. There's the spindle. There's the disk itself that stores the zeros and ones on it. A zero can be represented as like a spot where there's no electrons, where there's no electricity. And a 1 can be represented as a spot where there is an electron, where there is electricity. A file, like a Word file, can be saved as like a strip or along a section of the hard drive disk. So that blue area is the saved file on the disk. There's the ARM, which moves to the place on the disk that stores the data. And then there's some other things, don't need to worry about those. And this is a solid state drive. A solid state drive does not have an ARM, it does not have a spinning disk. A solid state drive is kind of similar, we'll jump forward for a little bit. A solid state drive is sort of similar to a USB in that there's no spinning disk and electricity is used to store the information on it. Solid state drives are higher quality than spinning disks. They last longer and they're faster. Solid state drives are higher quality than USB flash drives. They store more data, they access data faster. But the idea of no spinning disk is shared by both USB flash drives and solid state drives, like this one, a solid state drive like this one. The gold right there on the left is where it attaches to the motherboard. All right, mass storage. So mass storage is like hard drive disk or like solid state drives. So we're going to talk about mass storage. Mass storage, additional devices, magnetic disks, like hard drive disks. CDs are a type of mass storage. CDs have a disk, the CD-ROM. DVDs are a type of mass storage. The DVD-ROM is the spinning disk. There are magnetic tapes. Magnetic tapes have been used. They're kind of older, but there's tape memory, which nowadays is mostly used for glacial memory, which is like very long, like storage of things that don't need to be accessed very often, like archives are stored on magnetic tapes. Flash drives or USB drives, like this is a flash drive, a USB flash drive. And solid state drives, which are these. So those are types of mass storage. The advantages of mass storage over main memory. Main memory is the RAM, the memory that the application uses for in the middle of calculations. So advantages of mass storage over main memory: less volatility, lower storage, larger storage capacities, low cost. In many cases, can be removed. So RAM gets wiped every time you turn off the computer. It's expensive, we'll compare to mass storage. And RAM is stuck into the motherboard, whereas something like a USB can be pulled out and put back in. Okay, so we'll talk about CDs now. CDs work like hard drive disks. There's a spinning disk. So if you look at this, a magnetic disk storage system, you've got a spinning disk divided into sectors. There's a read-write head and an arm that seeks the spot on the disk where data has to be read from, and the disk spins in one direction. So the CD-ROM disk is very similar in operation to this hard drive disk. You've got an arm, you've got a read-write head. Okay, so that's your CD-ROM disk. And if you look at the data itself, data recorded on a single track consisting of individual sectors that spiral towards the outer edge of the CD. So if you follow the dashed line on the CD forms a spiral that goes from the inside of the CD to the outside of the CD. The spiral has a series of zeros and ones, or like spots where there is an electron or no electron, and the zeros and ones get read as a file, like a music file, an MP3 file. And this file gets interpreted by the operating system. The operating system says, oh, this is a .mp3 file, we should use a music player on it. And the music player will interpret the zeros and ones as music. This is something that was before CDs, but you've got a similar idea. You've got an arm, you've got a read-write head, which is the needle, and then you've got the data encoded as zeros and ones on the disk, the spinning disk. So this is a vinyl record, but it's the same idea Same idea as this spinning disk, and same idea as this spinning disk, this computer hard drive spinning disk. Whereas a USB flash drive has no spinning disk, but it also stores memory in a way that survives turning the computer on and off. Again, remember RAM, when you turn the computer off, the RAM gets wiped. When you turn the computer off, this doesn't get wiped. Same thing with this. And CDs as well. Okay. Now we're going to talk about data compression. Some of the stuff is a little complicated, so we're going to skim over some of it. We'll start with the first point: lossy versus lossless compression. So lossless compression is compression that doesn't lose any zeros and ones. It doesn't lose any data. The data quality is preserved. Whereas lossy compression loses some zeros and ones. The data quality is not preserved. So we're going to look at a photo. This is lossless, a lossless photo. And if we look at the grain on the top of the, so I'm going to tap my finger on the grain. But if you look at the grain, each grain is like a speck of grain at the tip of the plant, on the top tip of the plant. And if you look at the same grain, the same top of the plant on the lossy compression photo, for example, you look at the grain on the top on the left side versus the grain on the right side. Try to look where I'm touching with my finger. But you see how the grain on the right side is a little less sharp. It's a little blurry. Whereas in the lossless, it's not blurry. It's more sharp. So lossy adds blur. It makes it blurry. It makes it less sharp. But lossy also takes up less space on a computer. So there are different ways to make data take up less space on a computer. One example is called run length encoding. What run length encoding does is basically, let's say there's 100 zeros in a row on a computer. Instead of putting the 100 zeros in a row on the CD or on the vinyl or whatever, it'll just give the binary number for 100 and then put a 0. And that's supposed to signify that there are 100 zeros. So it'll literally write out 100 0 instead of writing out 0 100 times. That's called run length encoding. Or Huffman, I don't remember exactly, but there are different encodings. Now, what is the relevance of encoding? Why do we care about encodings? Well, encodings like run length encoding or Huffman encoding that I just mentioned, the thing where you say 100 zeros instead of 0 100 times, that causes things to take up less space. And so has anyone here ever seen a zip file? So like on a Windows computer, you might see a zip file. So I'm going to pull up an example of a zip file. Okay, so when you click compress to zip file on a Windows computer, or even a non-Windows computer, different computers can do the same functionality. Even non-Windows computers can compress the zip file. But what that does is it compresses the data using an encoding. The encoding I gave you is a very simple encoding, saying like 100 zeros instead of 0 100 times. But they have more complicated encodings that are more efficient and that can encode certain types of information in a more compact way. But what encoding does is it lets you compress something into like a zip file. Like this is one file is 2.zip or whatever. But these, and then a zip file can be extracted to get back the original information. So for example, in this zip file, there's an audio file.wav. .wav is uncompressed audio. There's a .docx, that's a Word document for Microsoft Word. And there's a .xlsx, which is a type of Excel file. Now again, from the computer's point of view, all these things, the music, the Word document, and the Excel document, are just a series of zeros and ones. But the file extension, the .wav, the .docx, the .xlsx, is a hint to the operating system of how this file, this series of zeros and ones on the computer, on the hard drive disk, should be interpreted. Should it be opened with a music player? Should it be opened with a Word document program? Should it be opened with an Excel? So technically, you could try to open a .docx file, a Word document with a music player. Now, the music would just be like random, incomprehensible sounds, or it won't open or it won't work. But technically, from the computer's perspective, it's all just zeros and ones. Likewise, you could try to open a music file, a .wav, as a Word document, but it would just be like random characters that don't make any sense and a lot of question marks and like strange glyphs. But yeah. So the reason let me get this failed. Let's retry that. But the reason encoding is important is because it allows us to compress data to take up less space. So I'm going to go back to our slide. Yeah. So encoding can be like a zip file, but also a lot of files are themselves already compressed or encoded. So if you think of like a music file, has anyone heard of .mp3 files or like a .mp3 player? So .mp3 is a music file type, and mp3 is a lossy file type, meaning that some quality is lost in the process of making it. So there could be a little fuzz or a little blur in the quality of the audio, but usually it's too small for people to notice. But the amount of data that's saved is a lot. It takes up a lot less space. But yeah, if we go to our, here's some examples of compressing images. So .gif is for small animations. .jpeg is for photographs. So if you've ever taken a photograph with your phone, the photograph gets saved as a JPEG file. A .tiff is used for like when you use a scanner. When you scan something, it gets saved as a .tiff. But different file types, the different file extensions like .jpeg are hints to your operating system of like how to interpret the data. And again, on the left is lossless. So if we look at this wheat on the left side, see how clear it is. And then if we look at the same wheat on the right side, you can see how blurry the grains are at the top of the plants. Now it's a little hard to see, especially if your vision isn't super sharp. But if you've been to the optometrist, if you've been to the eye doctor, if you've got glasses that fit your prescription, and you make sure they're clean, you should be able to see how on the right side is a little blurry, and this on the left side is more sharp. But yeah, I generally prefer lossless over lossy, but it does take up more space on the computer. Now we are 48 minutes in, so I'm going to show a couple more videos from YouTube. And then we'll be ending the class. So we covered what is a computer, inside a computer, basic parts of the computer. Then we did getting to know laptop. Let's do these two.
Ready to level up your Python workflows?
This is a
Python,
commercial.
the only Python IDE you need, built for data, machine learning, and AI professionals. Code smarter, ship faster. With
If you're thinking of buying a computer, you may have wondered, is a laptop right for me? Depending on how you plan to use it, the answer may be yes. In this video, we'll look at some of the ways that a laptop is different from a desktop to help you decide. The biggest difference is portability. Laptops have to be small and light so that you can pick them up and take them with you. Since all of the basic parts are built in, setting up a laptop is as easy as opening it. The downside is that the monitor is usually smaller than a desktop monitor, so you'll have less screen space. Another important difference is that laptops use a battery. The battery can provide power to the laptop when you're on the go, and it will recharge whenever it's plugged in. An added benefit of having a battery is if the power goes out, the battery can work as a backup power source. Instead of a mouse, laptops usually have a built-in touchpad, also known as a trackpad. You can control the pointer on the screen by using drawing motion with your finger. If you haven't used a touchpad before, it is a little bit different from else, and it may take a while to get used to. If you're buying a desktop computer, you can mix and match almost any monitor, keyboard, and mouse that you want. With a laptop, you won't have quite as much freedom since everything is built in. However, if you want to have the best of both worlds, you can use your laptop's ports to connect a separate monitor, keyboard, and mouse, basically turning your laptop into a desktop. And of course, whenever you want to, you can simply disconnect everything and take your laptop with you. As you can see, there are some important differences between laptops and desktops, so depending on your preferences, you can decide which one best suits your needs.
It's just the
Do
internet
you know
loading.
that you and your computer speak different languages? It doesn't speak Spanish or Swedish
It's just loading.
or Chinese. It speaks in ones and zeros. You can't communicate directly with your computer, but that's where your operating system comes in. The operating system, or OS, is the program that lets you interact with your computer. Together, the operating system and computer hardware form a complete system that determines what your computer can do. There are many different operating systems. Two of the most common ones are Microsoft Windows and Mac OS. Windows comes preloaded on most personal computers, while Mac OS runs on all new Macs. Operating systems aren't just for desktop and laptop computers. Mobile devices run mobile operating systems, like Apple iOS or Google Android, which are designed for interactions with smaller touchscreens. Before downloading a new program or application, be aware that it may not be available for your operating system. Some applications work on all devices, while others only work on certain ones. So get to know your operating system to see how it works and what it can do. GCF Global, creating opportunities for a better life.
Bot coding in AI Studio with Gemini 3 lets you build anything.
If you woke up this morning thanks to the alarm on your smartphone, or if you like watching videos or playing games on your tablet, you're using applications, also known as apps. An app is a software program that lets you do things, for lack of a better word. You'll find apps on all of your devices, including smartphones, tablets, and computers. Some apps help you complete tasks, while others are just for fun. Here are some examples of ways you can use apps. Mobile apps are apps that run on your smartphone or tablet. They can make many things in life more convenient. For instance, if you're looking for a place to buy coffee, an app like Google Maps can determine your current location and then recommend nearby coffee shops. Apps aren't just for mobile devices, though. The programs and applications on your computer can also be considered apps. If you've ever used Microsoft Word to create a document, or a web browser to visit a website or check your email, guess what? You've used an app. Some apps come already installed, but you can easily download or buy more online. Apps are about communication. Productivity, entertainment, and more. With so many possibilities, you're sure to find several apps that are perfect for the things you do.
Are you having trouble putting your computer together?
Okay, so they talked about apps. So the most commonly used app is a web browser. Like the most common one is Google Chrome. There's also Mozilla Firefox, Microsoft Edge, and its predecessor Internet Explorer. Apple has Safari. There are also a few others like Brave browser, whatever. But yeah, and so an app is a program that's installed on your computer. The CPU will execute the app. It will interpret. The app is just a series of zeros and ones. The same way Microsoft Word file is a series of zeros and ones, or a movie is a series of zeros and ones. And what matters is how those zeros and ones are interpreted. Are they interpreted as a Word file? Are they interpreted as a piece of music? Are they interpreted as a video? An application is interpreted as a series of commands that the CPU of the computer executes to do something, to interpret an HTML, an internet browsing file, to play music, etc. Now we've got 3 minutes until the hour is over. So I think I'll end it here. Tomorrow, this is a brand new course. This is my first time teaching it, and the curriculum is being created as I speak. Like I'm creating the curriculum like as I go along. So I'm not 100% sure what the next course will entail yet. I'm thinking we'll talk about like security, common scams, internet safety, things like that. But maybe we'll talk about different kinds of programs. But yeah, we'll do something new for next time. Again, this is lesson. So if I were to go to the slides again, so we've just finished lesson 1 of 4. Computer lessons for seniors, lesson 1 of 4. So we just finished lesson 1 of 4. Next class in a week, we'll do lesson 2 of 4, and then lesson 3 of 4, and then lesson 4 of 4. I look forward to seeing all of you. Thank you very much for participating in the class. Also on Saturdays, on the weekend, there is a website building class, how to learn to code your own website. And there's also going to be on Saturdays office hours to come in for any help or assistance. But yeah, thank you very much. This is the end of the class. The end of the lesson, the first lesson of 4.